So hello and welcome back to this next video where we are going to learn the Lagrange's mean value theorem. This Lagrange's mean value theorem is actually the one where you will get the questions in the exam. So that's why today in this video we are just going to see what is Lagrange's mean value theorem and how it works. So, for instance, let us consider the x and f of x axis here, and on this axis I have considered two values of x, that is a and b. Two values of x I have considered, and corresponding to these two values I have this f of a and f of b points. Now, what does Lagrange's theorem, Lagrange's mean value theorem, tells you that uh, the slope of this line joining the start point and end point. Can you tell me what is the slope of this line? The slope of this line is what? We say it is dy by dx, right? Dy by dx is the slope of this line. Dy is the difference between the y variable. The slope for this line is let us say m, and it is equal to what we can say dy by dx, that is difference in y variable upon difference in the x variable. So difference in y variable, you can see f of b minus f of a, it is f of b minus f of a, and difference in the x variable is b minus a. So this is the slope of this line, and as per this Lagrange's mean value theorem, if we draw any continuous and differentiable curve between these 2 points, okay, if we draw any curve which should be continuous and which should be differentiable between these two lines, then there must be some point C which should be in between A and B, and at that point, for that particular curve, the slope will be equal to this slope, the slope of this line. Okay, so for instance, if I draw something like this, okay, so I can see that somewhere at this point I'll get definite exactly the same slope as that of this line, or else whatever the way, straight line is already there. If I consider this straight line, we already have that proved, Lagrange's mean value theorem. Whatever the way we draw, whatever the curve, okay, whatever the curve we draw which should be differentiable and continuous, the slope for any of the point on that curve must be equal to slope of this line. So you can try any of this version, you can get at least one point. There can be many points. Say for example, for this curve we have somewhere here and one more at this point, okay, which are parallel to this one. That means the slope of these lines is equal to the line joining start point and end point. Okay, so this is what, and corresponding to this point, I can say this is a C point which lies between A and B, and which has the same slope as that of a start point and end point. Now let us consider the statement of this Lagrange's mean value theorem. So as per the statement, if f of x be defined in an interval a comma b such that first condition is f of x should be continuous within the closed interval a comma b, and this same f of x should be differentiable within an open interval a comma b. If these two conditions are satisfied, then as per this LMFT, Lagrange's mean value theorem, there must be C, there must exist some C which belongs to A comma B such that f dash of C is equal to f of B minus f of A upon B minus A. So this is what we have proved here. So here you can see this is the slope of the line joining start point and end point of this these 2 points, and f dash of C is the slope of any point on the curve. Now this slope must be equal to this line, and that point C must lie within A comma B, A and B. So let us consider an example, simple example. Later on we are going to solve the examples from the university question paper. But to understand this Lagrange's mean value theorem, let us consider an example of sine of x. If suppose f of x is a function sine of x and defined in between 0 and pi by 2, and then along with this the statement will be like verify Lagrange's mean value theorem for f of x is equal to sine of x. Now to verify this theorem, the steps will be something like this. First step is what? To check the continuity. To check the continuity of this function. And as you can see, sin x is continuous everywhere. You can write the statement here. Sin x is continuous everywhere. That's why sin x is continuous in 0 comma. I can write 0 comma pi by 2. Which is a closed interval. Along with this, in the next step, what you have to do, you have to verify whether it is differentiable, whether the given function is differentiable. So here you can check out that f dash of x, that means derivative of this f of x is equal to the derivative of sin x. As you all know that derivative of sin x is what? Cos of x. So derivative is possible, and the value for this derivative within this open interval, that means within 0 comma pi by 2, has all the valid answers. Okay, the answer for this f dash of x will be a valid answer for this 0 to pi by 2. That's why we can say that it is a differentiable as well. It is a continuous function, it is a differentiable function. Then as per LMVT, what we can say, there must be some C which belongs to what? A comma B, such that f dash of C is equal to f of B minus f of A divided by B minus A. Now here for f dash of C, we will take f dash of x. Here we have to replace this x with C. Okay, if I replace this x with C, I must replace this x as well with C. Then f dash of C will become cos of C, isn't it? F dash of C will become cos of C, and this will be equal to, see here, f of x is sine of x, and this one here is your A, and this one is your B, isn't it? So f of B, that means it will be what? Sine of B, that means sine of pi by 2. So this will be what? Sine of pi by 2 minus f of A is what? 0. So it is sine of 0, and divided by this whole divided by B minus A. So it is what? Pi by 2 minus 0. Isn't it? So from this, if I simplify, I will get cos of C is equal to sine pi by 2 is 1, you know, sine 0 is 0, and this is what? Upon pi by 2 minus 0 is pi by 2. So this is divided by pi by 2, or what we can say, it is 2 upon pi. Okay, so for this we can find out C, which is equal to cos inverse of 2 upon pi. So this is the answer for the C, and if I find out this in the calculator, when I find out this answer in the calculator, the value of C will be what? 50 point something, 50.49 something degrees, and which definitely comes between 0 and pi by 2. Pi by 2 is nothing but 90. So this number definitely comes between 0 and 90. So that is what we have to prove here, that C comes within 0 and pi by 2. That means C comes within A and B, and then you can write hence LMVT is true. Okay, so thank you for watching, and we will see the solution of university questions within in the next video.